4. Stable at step 3.
So that's a great sign right there. Stable at step 3. Everything is at flight pressures. We're now the only thing left, Joshua, is that final status check with the whole team.
25 seconds.
Status check.
Go Atlas.
Go Centaur.
Go Lucy.
Seven, 6, 5, 4, 3, 2, 1, 0. Liftoff. Atlas V takes flight, sending Lucy to uncover the fossils of our solar system.
Attack clear. RD-180 propellant utilization has on a closed loop control. The vehicle has begun the yaw roll maneuver. Now, 30 seconds into flight, vehicle is 0.6 miles in altitude, traveling at 939 miles per hour. RD-180 performance continues to look good at this time. Engine pump speed and injector pressures are in family for this thrust level. Atlas vehicle attitude remains stable at this time. Attitude rates are near zero in all axes. Now at T plus 70 seconds into flight, vehicle is 4 miles in altitude, 0.2 miles downrange distance, traveling at 1,200 miles per hour. Mach 1 Atlas is now supersonic. Vehicle is now passing through max Q, maximum dynamic pressure. The vehicle is now throttling down slightly. RD-180 engine parameters continue to look nominal after the prior adjustment to thrust level. Approximately 2 minutes remain in the Atlas booster phase of flight. The Atlas V rocket weighs now just 1/2 of what it did at launch, running propellant at a rate of 2,600 pounds per second. Vehicle now executing closed loop steering. Centaur reaction control system is now pressurizing the flight levels.
So beautiful launch sequence there. We do have another minute and a half or so to go with the booster in operation, getting Lucy.
We're now just under 3 minutes into flight. Atlas is 33 miles in altitude, 59 miles downrange distance, traveling at 5,600 miles per hour.
So Lucy being lifted up out of the atmosphere by the booster, getting on its way into a park orbit before we get towards...
All first stage vehicle systems are operating as expected this time.
Future portions of the launch activity, we have the Centaur multiple burns ahead and spacecraft separation.
Yeah, the big milestone we should see, Josh, coming up is booster engine cutoff, which would be the first stage cutoff and stage
The main
separation.
engine is now throttling to maintain a constant 5G acceleration limit.
We're going to see a few things happen pretty rapidly. The booster will cut off just after 4 minutes, and then within the next 15 seconds after that, we should see the Atlas separate from the Centaur, and then the Centaur engine ignite for its first burn.
Centaur has begun the boost shield end sequence, and the RD-180 is now throttling to maintain a constant 4.6 G acceleration limit. Boost shield end sequence has completed, and we have the booster engine cut off and a successful stage separation event.
What you're seeing on screen is an animation that's being driven by actual telemetry.
Please head on the RL-10.
So we are watching these things in an animation happen here, but they're happening in real time as well.
And that's one. We have ignition for the first burn.
All right, so there we go. We should see the fairing jettison here.
We have indication of good payload fairing jettison.
And there we go. All right, Nick, so that wraps up the first round of major milestones here. Still very much in the middle dynamic flight.
The P system on the RL-10 is now in an open loop burn-off mode to burn off excess fuel in the early portion of this burn.
So walk us quickly through, Mick, what are we looking for in this burn and the next one?
So this burn's going to end with Miko getting Centaur and Lucy into its and get into MES 2, which will get us into that transfer orbit, getting Lucy on its way.
Awesome. So that's going to do it for now. Finishing up the initial launch activities, everything sounding like it's going perfectly. Daryl, back to you.
Thank you, Joshua and Mick. A beautiful launch out here from our vantage point. Incredible. All right. Lucy was built at the Lockheed Martin facility in Colorado before arriving at the Cape Canaveral Space Force Station for launch. Engineers at Lockheed's Waterton facility use lessons learned from prior spacecraft like New Horizons and OSIRIS-REx to build Lucy.
And in July, Lucy was packed up and flown on board a United States Air Force C-17 cargo plane from Colorado to the launch and landing facility runway at the Kennedy Space Center. From there, Lucy was transported to an Astrotech Space Operations Processing Facility in nearby Titusville for final preparations before liftoff.
Yeah, just a few miles from here before it was brought to the pad. For more about how Lucy was built, let's send it over to NASA's Megan Cruz.
Hey, Daryl. Yeah, right now I'm joined by Ari Vogel. He's the Deep Space Exploration Director at Lockheed Martin Space. How are you?
I'm doing wonderful. Thanks so much for having me.
Wasn't that just a beautiful launch? What did you think about that?
Incredible. You know, seeing it go over the clouds and brighten up the whole sky was just fantastic.
Yeah, to see it rise over the clouds, because, you know, we lost it a little bit because of some cloud coverage, but then it just rose out of it. It was so beautiful. And,
yeah.
You know, I really wanted to talk to you because your team at Lockheed Martin Space knew that you were going into a project that would require you to develop a spacecraft that would travel farther than any other solar-powered spacecraft ever. I mean, was that intimidating?
You know, it was a really exciting challenge to solve, right? And obviously, the most prominent feature of Lucy is their big solar arrays. Each one is about the length of a bus. And, you know, what we did is we basically just broke the problem down into smaller pieces and then applied systems thinking to make sure that the design trades we were doing didn't impact, or that we fully understood the impacts for over the 12-year mission. So, you know, being the farthest solar-powered spacecraft is certainly something that was difficult to prepare for, as is going to a record 8 asteroids in one mission. But that's why we have such a comprehensive Test Like You Fly program at Lockheed Martin, and we took it through the ringer at our facility in Denver.
Yeah, and you did it all within 14 months. That's during a pandemic. That's incredible. Can you talk to me about the challenges of that?
Yeah, you know, it's really awe-inspiring. I mean, to be able to build a one-of-a-kind spacecraft during normal circumstances is incredible. And the team just really pulled together, didn't miss a beat, connected and collaborated, you know, made sure that we didn't have any mistakes. And it really accelerated some of our digital transformation initiatives too, having to work during the pandemic. And not a single shift was missed during integration and test due to COVID. So team just did an awesome job, leadership with the preparation and the over-communication and the transparency. And then all the team, you know, just didn't let their commitment to Lucy waver. And I think the thing that I'm most proud about actually is that through it all, we still continued all of our STEM events, all our mentoring, our coaching, Lockheed Martin, NASA, Southwest Research Institute, hundreds of thousands of hours into that. So it was really, really a great job. And
really quick, you also built the antenna that's on there that's going to help us communicate with Lucy. Can you tell me a little bit about that? Yeah, we did. 6.5 foot wide antenna that we built. Main job is to do the communication between the spacecraft. And, you know, it's also going to send back some of the first images of the Trojan. So the whole team is super excited for that. Yeah, absolutely. Thank you so much, Ari. I really appreciate you being here today and for bringing Lucy to life. So thank you.
Thanks for having me.
All right, Daryl, back to you.
All right, thank you, Megan. And in case you're just joining us, we here at NASA are at the beginning of Lucy's 530-mile journey to the Trojan asteroids beyond the sun, going to the same orbit, Marie, as Jupiter.
That's right. It was a beautiful launch here. We could see it light up the water behind us, and we actually had a gator in the water just behind us. Oh, joining us for liftoff. Yeah. Lucy is named after a skeleton fossil more than 3 million years old. Lucy was an early human ancestor, and the Trojan asteroids are fossils, too, of how planets were formed.
Beyond the asteroid belt are fossils of planet formation, known as the Trojan asteroids. These primitive bodies share Jupiter's orbit in 2 vast swarms, leading and trailing the planet. Now, NASA is preparing to visit 7 asteroids, embarking on a 12-year odyssey that will span Jupiter's orbit. One mission will explore these objects for the first time. Lucy, the first mission to the Trojan asteroids.
And another special guest that we had watching the launch from the Atlas Spaceflight Operations Center was none other than NASA's Associate Administrator, Bob Cabana. He is standing by with Blair Allen of NASA Edge. Actually, they're telling me that we lost audio with that group, so we will come back to that if we can, but while they try to work out their audio issues. But Daryl, we had a really unmatched view of launch here. It was just spectacular.
Yeah, it was incredible because we're sitting, you can't really tell, but this behind us is the Kennedy Basin,
right.
The turn basin where they brought in, the space shuttle main tank, as well as just recently the core stage for the Artemis rocket, which is in the VAB right now getting stacked. You're looking at the flight of Centaur and Lucy. We are L plus 11 minutes and 26 seconds as we cruise along, and we want to talk a little bit now about the message that Lucy is going to be sending.
That's right. Lucy is carrying something on board. Aside from her scientific instruments, she's got something a little more philosophical. There is actually a plaque affixed to the side of the Lucy spacecraft, and it contains quotes and messages from artists, poets, and thought leaders. And the plaque is meant to serve as a time capsule of sorts for our own descendants. You see, after Lucy's 12-year mission is complete, the spacecraft will remain on a stable orbit, traveling back and forth between the Earth and the Trojan asteroids for perhaps hundreds of thousands of years. And one day, in the distant future, our descendants may be able to retrieve Lucy. There it is, the plaque you can see on the side of the spacecraft. Yeah. This was before Lucy was packed inside the payload fairing. But this is meant to be a relic for our descendants of the early days of humanity's exploration of the solar system. And when they do, they will see some great messages. We'll see those. We'll talk more about those in just a couple of minutes. We actually have. We do have it. So this is a representation. It's hidden a little bit behind your computer, Daryl.
Oh, yeah, let me get that down. Thank you.
But this is the actual plaque on the spacecraft is about a tenth of the size of this, so this is blown up.
Yeah.
But it's got a diagram on it. This shows the positions of the planets as they are today on the day of the Lucy launch.
That's right, and there are some great quotes. You mentioned some of the great philosophers and thought leaders over time. Down at the bottom left, you can see that one there is from Albert Einstein. The important thing is to never stop questioning. And then in the middle, we've got the Beatles. In fact, every single Beatle is here, including John Lennon. And he says, we'll all shine on like the moon and the stars and the sun. And then up here at the top, actually right here on the far right, we've got Amanda Gorman, who just came to recent fame at the presidential inauguration. She actually wrote this poem specifically for Lucy, and there's a great quote in here. She says, hope implores us, may the ancient study and the uncompromising core of us to keep rising for an earth more than worth fighting for. Great words from a young poet.
Yeah, she's an amazing poet. Just blows me away. We are going to now get a look at some more of the messages that we intend to leave behind for our descendants. Take a look.
And this is what I want to say to people, to beings, to consciousness who are so far away, I can't even imagine them.
To represent our culture accurately, we should include hopelessness, risk-taking, the role of fortune, good or bad.
To understand each desire has an edge, to know that we are responsible for the lives we change. No faith comes without cost. No one believes without dying. There are no curses, only mirrors held up to the souls of gods and mortals.
Remember, you are all people, and all people are you. Remember, you are this universe. This universe is you.
I would just like to say that this wonderful emissary to the Trojan asteroids is itself a message. Lucy speaks for all that is best about human ingenuity, curiosity, and endeavor.
Do you still have birds that wake you up in the morning with their singing, and lovers who gaze at the stars, trying to read in them the fate of their love? If you do, we'll recognize one another.
And receive those words inscribed on a plaque from all of us, for all of us, filled with those aspirations and that inspiration and that imagination that we need so much right now.
A little noisy, but I'm so excited. Lucy is going back in the sky with diamonds. Johnny will love that. Anyway, if you meet anyone up there, Lucy, give them peace and love from me.
All right, we've got that audio issue taken care of, so we're going to go over now to NASA Edge's Blair Allen, standing by with Bob Cabana. Blair?
Thanks so much, Marie. Yeah, sorry about the technical difficulties. You know, the launch was so impressive, even our gear was affected. But Bob, it's really impressive to see this launch this morning. Tell us, how is it from your perspective?
Well, first off, from my perspective, I got my very own NASA Edge microphone. I'm just elated. Now, Blair, you know, anytime you see a rocket ship leave planet Earth, it is an experience. It's a feast for the senses, sight, sound, and feel. It's emotional. And having Lucy on board, I mean, this is the coolest darn mission, going to the Trojan asteroids. Looking back at the beginning of our universe 5 billion years ago, absolutely amazing.
And that's kind of what's impressive. I mean, we're talking about this important science mission, but here at Kennedy, we've had 24 launches so far. What's going on?
Well, I tell you, first off, I could not be more proud of our NASA team, our contractor civil service team that has persevered through this pandemic, not missing a beat, you know, making all our missions. I mean, we've launched humans to the International Space Station for the first time since the end of the shuttle program during it. We've launched Perseverance to Mars. You know, we're getting ready to launch James Webb here in December. That's going to be amazing. And getting Lucy off on time. You know, if we didn't get off in this launch window, we're talking another year before we launch.
Yeah, and that is impressive to see how things came together so perfectly. But tell us a little bit about what's coming down the pike. We've seen a lot of things happen here at Kennedy and lots of things to look forward to.
Well, absolutely. You know, I mean, first off, from a science mission point of view, of course, next month we're going out to the West Coast for DART. Then we're coming back here in December for IXV. In December, down in French Guiana, we're launching James Webb. What an amazing telescope that's going to be. A 21-foot mirror you know, and then a solar shield, a sun shield the size of a tennis court. You know, they talk about the 9 minutes of terror landing on Mars. Right. We're talking 4 weeks of nail biting as that thing unfolds. But to look back 13.5 billion years, almost to the beginning of our universe, you know, 350 million years from the beginning, it's going to be amazing. And then over in the vehicle assembly building over there in High Bay 3, stacked up, is that awesome space launch system, that Boeing core stage with the Northrop Grumman solids and those 4 Aerojet Rocketdyne RS-25s. Yeah. The Orion spacecraft rolls over here on the 19th, stacked that on top. It's going out to the pad for a wet dress rehearsal, and then we're going to launch it to the moon. We're going to do that first test flight without crew in preparation for going back to the moon in a sustainable way so that we can go on to Mars. Just so much going on.
I love it. Thank you so much for being on the show. From Center Director now to NASA Administrator, back to you, Marie. Great things here at NASA.
All right, thank you, Blair. One of the asteroids Lucy will visit, Euripides, has already given researchers a recent surprise revealed by the Hubble Space Telescope. Take a look.
On January 9th, 2020, NASA's Lucy mission team revealed that the spacecraft would be visiting not 7 asteroids as planned, but 8. As it turns out, Euripides, one of the Trojan asteroids along Lucy's path, has a small satellite or moonlet orbiting it. Finding these tiny new worlds before Lucy is launched in 2021 means that the team can investigate their orbits and plan for more detailed follow-up observations during flybys. Dr. Keith Knoll and other Lucy Science team members have been using the Hubble Space Telescope to search for satellites and rings around Lucy's targets. This can be challenging since the raw images are often filled with bumps, blobs, and diffraction spikes. The Lucy team didn't see any evidence of a new satellite until November 2019. After experimenting with the brightness and contrast on the Hubble images, Dr. Knoll saw a peculiar faint spot near the much brighter Euripides. Dr. Mike Brown, another team member, noticed the spot showed up in a slightly different position on another set of Hubble images taken 2 days later. This change suggested that the spot was an orbiting satellite. The team went back to Hubble and got 3 more chances to make observations of the possible new satellite. On the first 2 tries, the little moonlet was nowhere to be found. But on the 3rd observation, on January 3rd, 2020, they found the possible new satellite again. It was clearly visible next to Euripides, which was over 6,000 times brighter. This huge difference in brightness suggests that the satellite is less than 1 kilometer in diameter, very small compared to Euripides at 64 kilometers. With a few more Hubble observations, the team pinned down the new satellite's orbit, and they proposed a name. The International Astronomical Unit approved, and from now on the little satellite will be known as Quetta, after Enriqueta Basilio, the first woman to light the Olympic cauldron. Evidence indicates that the Trojan asteroid Euripides is the largest fragment from a massive asteroid collision that happened billions of years ago. It is possible that the new satellite Quetta is a remnant of that catastrophic event. Whether with Hubble or with the Lucy spacecraft's flyby, each observation enriches our understanding about the Trojan asteroid's formation and Euripides' relationship with its newly discovered companion. The discovery of this new moonlet around the Trojan asteroid Euripides is just a preview of the incredible scientific knowledge that will be captured by the Lucy mission as it explores this area of our solar system.
All right, our next guest is one of the great minds behind the mighty Atlas V, which just had another spectacular launch here. He's standing by with Franklin Fitzgerald from NASA Edge over at the ASOC. Franklin?
Yeah, thanks, Marie. I'm here with Scott Messer, ULA Program Manager. Scott, how did the launch go from ULA's perspective?
Well, it was near perfect so far. We never claim success until we separate and get the spacecraft where it wants to be, but so far the first stage was great. The countdown was very quiet, and it's a beautiful launch so far.
Great to hear. This is a mission unlike any other before it. Can you tell us exactly how unique the trajectory was for the Atlas V on this mission?
Yeah, so certainly the trajectory for the spacecraft is very unique, probably never been done before. But from an Atlas standpoint, we've launched many planetary missions over the years, and we just kind of did our standard thing in order to get the spacecraft ready to go.